Yeah, you want to start? We'll buy a second here by just doing some quick introductions. You want to start over there, Ryan?
Yeah, I'm Ryan Rowland. I'm the data chief for the USGS Utah Water Science Center.
Rumsey, hydrologist, USGS.
Public Books Studies with the direction of what we can do. Joe Addis, Compass Minerals. Phil Brown, Run from Cooperative. Jake Necke, Utah Geological Survey. Andrew, Utah Geological Survey. John Loffer, Wildlife Resources.
Tim Sarvin, Forestry Fire and Seedlings. Kyle Stone, Division of Wildlife Resources. Let's start back there. Ryan Doherty, Cardio.
Emma Whitaker, Forestry Fire and State Lands.
Chip Harris, Division of Water Quality. Travis Anderson, Morton Salt.
Angela Don, Forestry Fire and State Lands.
From the suspicion at the Partial Cooperative.
Mike Freeman, USGS.
AK.
USGS.
Awesome. Let's see. So, Christine, are you ready to do yours? Maybe we can just start by hopping into that, and then we'll go into that.
I think I also can't share.
Oh, thank
you. All right. So I believe we're going to start with lake updates. So Ryan's going to walk us through some lake elevation and ETO information.
Okay, and then we'll transition to Christine a little bit later. So go ahead, next slide. All right, lake surface elevation, South Arm, showing data from October 1st, 2021 through the current period. Y-axis is elevation in feet. And the dashed line, horizontal dashed line, is a period of record low, 4188.5. That was set in late 2022. The most recent daily value that came in for May 25th, we made these slides yesterday, so the most recent daily value we could compute was for the 25th. It came in at 4191.9 feet. That's about 0.8 feet higher than the North Arm right now, and about 3.4 feet above this period of record low for this site. So you see we had a seasonal decline of about 2.7 feet in the South Arm, and we came up 1.6 feet if you include this little spike in the most recent data, which was really related to a multi-day sesh event. If we take that spike out, we came up about 1.3 feet. That was our seasonal rise. That's due to spring runoff, and you can see water levels are currently appear to be starting to decrease. Next slide. Okay, same type of plot for the North Arm gauge. The daily value for May 25th came in at 4191.1 feet. That's 2.6 feet above the period of record low of 4188.5. So 4188.5 is the period of record low for both the North Arm and the South Arm. So we're only about 2.6 feet above that right now. Next slide. Major surface water inflows. These are these graphs show the daily discharge in cubic feet per second on the y-axis. The bold black line are the computed daily values. The shaded zones are the percentile classes based on the period of record for the gauge. And I'm showing data from October 1st, 2024 through the current period. So you can get these plots very easily now from each gauge's real-time page. We call that the monitoring location page. It's very simple to bring these types of plots up, which are very useful. You used to be able to access those through WaterWatch. That website's gone away. And you can learn more about data updates or the way we present data on the web via the USGS water data blog website. I encourage you to take a look at that. The most recent daily values coming in, the bold black line for this site, Bear River near Corinne, you can see are well below the normal range, which is this kind of light green shaded zone. We're currently in this 5 to 10th percentile range, so much below normal flows at Bear River. The little note top right, the cumulative flow passing that gauge for water year 2026 for this time of year comes in at 491,000 acre feet. And that's just below 25th percentile for this site. So well below normal cumulative flows at this site for this water year. Next slide. Same kind of plot for the Weber River near Plain City. The most recent daily values shown by the bold black line. They're well below the below normal or the normal range. So now we're in again that 5 to 5 and 10th percentile range for current flows. The cumulative flow passing this gauge for water year 2026 is about 48,000 acre feet, and that's just above the lowest we've recorded this year for this time of year. Okay. Next plot is for the Goggin Drain near Magna, Utah. And you can see the low flows at this, or the current flows at this site are well below what we've seen historically. This full black line is below any of the shaded regions. So we're setting record lows right now. But the cumulative flow of this gauge so far this year is 436,000 acre feet, which is about the 25th percentile. So current flows are really bad, but overall for the water year, we're about the 25th percentile. Next slide. Okay, this is Great Salt Lake Farmington Bay outflow. Current flows below the normal range, in the 5th to 10th percentile range. Cumulative flow at this site so far for this water year is about 191,000 acre feet, and that's about at the median for this site so far this year. So if you add all those acre feet values up for water year 2026, I get 1,166,000 acre feet. Relative to last year, the value was 1,027,000 acre feet. So this year, we're actually 139,000 feet above what was measured last year. Okay. All right. At the new breach, as you all know, we make field measurements of discharge on a monthly basis during calm conditions. So this is showing the field measurements for the south to north flow. So on the y-axis, it's cubic feet, and on the x-axis, we're showing data from October 1st, 2024 through the current measurements. The last few measurements listed on the last two bullet items here have come in at about 770 cubic feet per second. AK does a lot of this work. That's why he's here today. So you all know. And so those last two measurements show flows have leveled off slightly, probably in agreement with lake levels kind of leveled off, and now they're kind of on a slight downtrend. The most recent measurement was May 12th at 771 acre feet. Yes, sir.
Just a quick question on the figure of the 130-ish thousand acre feet extra that we have this year. Is that for this date, or is that for total of last?
No, that's for this date, for this time of year. Yep.
And that's, Ryan, that's surprising though. Is that a timing issue, you think, that we got that late snow last
Or is
year?
that conservation efforts that are successful?
Yeah.
Yeah, we were wondering about this on the car ride over. One thing that sticks out is the Goggin Drain. So this year, 436,000 acre feet. Last year, 111,000 acre feet. So significant jump at that site. Yeah.
So did the runoff continue later last year? Like it looks like it's more or less concluded for this year.
Yeah, likely for
extend
sure.
quite a bit?
For sure. Yeah,
Okay.
without a doubt. Yeah, runoff was dismal this year. Was not good this year statewide, right? We talked to people in the know for what's happening at the Goggin Drain, and there was some water management that was happening. So big picture, more water passing the Goggin Drain relative to last year, and there were some water management activities related to that. I don't have a lot more detail on that. It was related to the I think the duck clubs.
Off the top of your head, do you recall what the total inflows for last year's water year was?
For the full water year, I don't recall that off the top of my head. All right, similar plot now. These are discharge values at the new breach. Now we're looking at north to south flow. So same type of plot, y-axis is cubic feet per second, and the same period, October 1st, 2024, through the most recent measurement that we have at the site. The last two measurements, April 24th came in at 38 CFS. And then May 12th came in at 35 CFS. And all the values shown on this plot are relatively low, kind of in this range. And I want everybody to keep in mind that there's very, very high uncertainty associated with these measurements. We think they're biased high. So these true values could be significantly lower than this. So keep that in mind. Next slide. Okay. As you know, we're operating a gauge at the lakeside breach at the far west side of the Railroad Causeway. So the plot is showing the discharge values at that site in cubic feet per second on the y-axis and showing data from October 1st, 2024 through the current period. The recent data, this water, a lot of the data, most of the data for this water year are showing basically no south to north flow at this site. We do see some periods of north to south flow. That's these values that are below the zero line is right here. The negative values are north to south flow. So you see some north to south flows in the data for this water year. The last couple of measurements at this site, March 9th, 2026, we measured 151 CFS north to south. April 2024, hardly any, well, about 1 CFS north to south. And note the effort to get this measurement on this big north to south flow event in March. That was a good effort to get that confirm that 150 CFS-ish north to south flow. But basically no south to north flow at this site. Okay, that's it for me. Any questions?
So the reason why there's no south north flow is the elevation of the lake is below 4193. That's usually when we start to see flow going across the lakeside breach. And all that water is across the last time. It's not in Oklahoma.
Other questions for Ryan or mine or Andy? Okay. I'll just,
Just on the stuff that you're seeing from the Inland Basin, have you guys attempted to quantify that at all? Or you just have those point in time flows?
So we're basically taking those stream measurements and then trying to estimate it based off of the elevation of the daytime records that we're still recording at the lakeside breach. So we're providing estimates based off our. It's not as accurate as having a velocity sensor that you have velocity to determine what the discharge is. So I agree with her.
Okay, thank you. And we're in discussions, right, about
monitoring that. Yep,
Awesome.
we're on it then.
thanks, Christy.
All right, quickly salinity where we're sitting at now. Here's a plot of the last 3 or 4 years or so starting in October 2022. Our lowest salinities for this spring were on April 7th, measured on April 7th, around 113 to 118 grams per liter. And relative to our fall high, we did about 8 grams per liter at our site 3510 in Gilbert Bay and 11 grams per liter at our site in Carrington Bay. And then we have our most recent measurements are from May 20th. So last week we was out collecting water samples and just ticked up ever so slightly per liter. And relative to last May, we're up anywhere from 1 to 6 grams per liter to this time last year. Our volume weighted salinity values were pretty similar, April 7th and May 20th. So for our upper brine sitting at 117 grams per liter, we consider the full depth all the way to the bottom of the lake. We're getting 117 grams per liter also for April, and it ticked up slightly for the May estimate or May measurements to 118 grams per liter. Looking at salt mass, we continue to go down. So our most recent estimate, May 20th, is 847 million tons, and we're still following that same trajectory. We've been on a decline of about 28 million tons per year. And just integrating all of that into our isomass plot, you can see we're sort of at the low end of the masses that we've observed, a low end of salinity as well. 118 grams per liter, 847 million tons, sitting at 4191.9 feet on May 20th. So that's our salinity update. So I will stop sharing and then also want to unless there's questions.
Thank you. I apologize, I was late. Yes.
Same meeting.
Same. And it went late. So did we talk
There's
about,
reductions, but that was.
Okay.
I
All right.
think that's
thank you very much. So, thank you for the update on the lake conditions. Our primary objective today with this meeting is we really want to try to get our arms around this nitrogen issue. And we think about what kinds of options we might have in the short term. And what kinds of recommendations can we make to forestry, fire and state lands and water quality regarding the berm? I think it's probably to be even more focused. And so we've got with our agenda, the intent was to first talk about what the problem is, so we understand why we're doing this, what are the conditions we're seeing today. I think from what Christine was just talking about with the salinity, we see, our salinity is right where we want it at this stage. And but what we want to talk about is the nitrogen, and how significant is that, and then ask Christine to do her magic and run through a number of different scenarios to look at, try to bracket some what if concepts. What if we do this or that? There's still a fair amount of uncertainty in all of this, but I think with the information we have what we have, and so I think we want to just try to look at, well, what kind of trajectory have we been on, and what kind of trajectory do we want to be on going forward. So that's really what we're hoping to cover today. And ideally, we could have a recommendation at the end of this meeting, but if not, hopefully we'll have some clear action items on what we need to investigate, prep work so that next month in June when we meet, we can take some recommendations. So I know I had circulated our summary from our meeting in March, and just wanted to see if there's any comments on that.
Hey, Jeff, just a quick comment on the agenda. I want to make sure that today's discussion, we kind of discuss, where we're at today, and then also maybe if we needed to, if you would consider making a recommendation prior to that. So that's on the table, because I think like with this whole nutrient issue, we really ought to think about whether we want to do something this year. And I think if we wait till our June meeting, those are the few weeks that delay, any import of nutrients and salts that we may want to see the reach. So if that's on the table, I think we should discuss that today and see if that's as urgent as we think, or if it's, if the group thinks that it's not, then obviously, we can wait. But I think we're talking about modifying the berm, waiting till June feels funny if we're going to raise it right back up in November and just short of that with no benefits from it. So anyway, I just want to throw that out there. Maybe consider whether or not any action is more urgent, or if we want to consider that today.
Great. Well, thank you. So just, I guess this is just a point of order in terms of our meeting summary from last meeting. Were there any comments on that? And if not, entertain a motion to approve them. Thank you.
Second.
Thank you. And any, I guess, vote for to approve them. Say aye. Or not want to approve them or have questions on them. All right. Well, it's been approved unanimously. So let's jump back in. Sorry, I think go back through this stuff. Did you talk about membership, or should we talk about that?
We haven't, and I do think it's. I think we have discussed having some trusted at some point. I think that would be a good time to discuss that again. But what do you have?
Well, we've had some changes and some proposed changes, and here you can see the who our current standing committee is. We have a member And then a voting member, we have a couple of non-voting members, and then everybody or most everybody has an alternate. And one of the proposed changes was for Andrew and Elliot to switch. Andrew is currently our voting member. Elliot's been our alternate, and they had suggested or asked even if they could make that switch. So Elliot would now become our voting member.
You guys are okay with it?
I don't know why Andrew hates us, but I Elliot as well.
Love you all.
What's Mr. University?
What's that?
We need to edit Mr. University.
Oh, yes, this is January
Yeah, I get it.
2025.
Yeah.
So I guess any concerns with that?
As long as they start bringing cookies as well.
No.
No. Looking at notes. Go ahead.
Do we need to vote on these things, or are we good? I think this just seems like
I think
something.
we're good.
I would also suggest, well, not suggest, I'd like to take off Mark Reynolds from US Magnesium. I don't think we need that anymore, but I would suggest that based on, with with Cargill and Morton still, attending these regularly, perhaps you guys can talk together about what would be appropriate to manage or I guess represent South Arm mineral industry among the two of you. And maybe it's a, primary alternate kind of relationship we all have, but maybe you all can propose how you'd like to handle that. Yeah. And I don't think we could put you on the spot here today, but maybe that's something for the next meeting, if that's okay.
Yeah, exactly. So, so if you guys can talk about that, we can chat offline too if we need to. And then the third one, Bill Johnson mentioned to Angela that Paul Jewell is asked to be taken off the list as his alternate at the University of Utah. I don't think he proposed another alternate yet.
He had a couple of names, but he said it was more a matter of what kind of expertise. So he suggested, and I don't think he's asked him, so never mind, but he suggested Michael Warner, which he's an apologist, Jacqueline Winter, the microbial biochemist, or at USU, Brian Kirsten, is a fluid mechanist, or David Tarbot, who's a hydrologist. So I think it just depends on what the community feels in area that's really stuff and
Great. So we'll follow up on that. And then Ben, you mentioned adding somebody from Utah State.
I think that just given the amount of work that they do in this sphere, it would make sense to have someone from Utah State represented. We also, but we also have, the other research universities pretty well represented. So I think Utah State is a natural fit from my perspective. But I think in the past, Brian Crookston had expressed interest, but probably can't make it in person. So as long as we're okay with him joining virtually, I think we could probably re-extend that invite and get him in attendance. But I think, David Tarbottom are best.
He was gonna say David was mentioned by Bill and he'd be good.
So maybe we can revisit that and then at our next meeting, figure out the South Arm industry, Utah State, and its replacement.
Yep.
Does that work?
Perfect. So we primarily today just wanted to make you aware of some of these changes and some shifts and where we're headed there. So guys, if you have any ideas or other people or that you think should be included in these conversations, me or Angela or Ben, know. All right. Well, let's move on to the issue at hand. I asked Kyle if he could kind of give us an overview of the observations that GSLEP has been making and their researchers and TAG have been talking about over the last 6 months. I think really the monitoring work that they've done, amongst that whole group, had identified this concerning trend. And I wanted to make sure you all haven't had a chance to watch the video or been involved.
Okay, so one of the things that we were seeing this year is in respect to.
Sorry.
Okay, so our chlorophyll measurements that we take, these are taken every 2 weeks in the lake. So I think uncertainty was a great word to put into this, and trend is probably a strong word to use. So these are the graphs that we present at our CAG meeting. So most of you have probably seen some version of this. This is for the current year, 2026. And so the y-axis is going to be concentration in micrograms per liter by month. And then we have our minimum and maximum are going to be the gray dashed lines. The solid gray boxes are 25th to 75th percentiles. The dark dashed line is the 5-year average. The bold line is the long-term average going back to 1994. And then we have our current year in red, and then 2025 is going to be in the gold kind of yellowish color. And the thing that is concerning, and it's hard to see on this graph, is the steep decline in December in chlorophyll values, and then that kind of bottoming out in January, and then that steep rise. And it's one of those where, if anybody remembers back to the TAG meeting in April, we actually didn't have this bottom point because we went from, it was roughly 70 micrograms per liter in late November. It was 36 in mid-December. It bottomed out to 6 in early January, and then went back to 75 by late January. So in the span of from, I think it was December 18th to January 20th, we went from 70 to 6 back to 75 with very few shrimp in the lake. So that was the concern that caused us to investigate a little bit more. So if we look at, this is our same basic data. This is the average concentration kind of spread out on that multi-year scale. So 2013 to 2026, the vertical lines that you can see kind of making up the grid square, it's going to be centered on January because it's really that midwinter period is where we're seeing this kind of concerning trend. And if you look at kind of the historic record, the 90s up prior to 2013, they really tend to look almost like 2017, where it's kind of an average year where there's some variability, and we do see some decreases, we do see some increases. This is likely sampling error going out every 2 weeks. This could be solar exposure changes. We're not sure what's driving these things. There could be several factors that go on. You can definitely see the influence of big runoff years like 2023, how it's, over here and very steep and dramatic. But even then, we do see drops at certain times. 2014 is another example of like a really good kind of normal year of what we expect to see over the long-term average. And then we get into some of these more concernings like 2026 over here, this really steep decline in January. We saw this similar effect in 2021 and in 2015. So it's not a new thing by any means. The most alarming thing is the degree to which the variation is. I mean, if you look in like relative percentage, we lost roughly half in 2015, maybe 2/3 in 2021, and almost 80% in 2026. And the other thing that goes along with this is the water clarity stays the same. So the lake is dark green, just like we would expect, but for some reason, there is a degradation or loss of chlorophyll A fluorescence. And as we scratch our heads and talk about this internally, talking with Gary, talking with other different people, we've kind of determined that chlorophyll A is not being consumed and changed like we see in the summer months, where, all these dips in the summer months and the bottoming out, the lake goes clear. Your Secchi transparency goes from, 0.2, 0.3 meters to 4.5, 5 meter depth. And during this time period in January, we're staying in that same 0.3, 0.4, but our chlorophyll A values are than the bottom. So it's an odd response that we're not.
So was that one measurement at bottoming out?
Yes,
And in 2021, can we see two measurements there?
yes. And these are averages of our 17 different sites. So this is an average across the south arm. But yes, that is one measurement. And that's why we didn't present it in tag, is because we thought we messed something up somewhere in our process. We run everything against 2 fluorometers now. So we have the old TD 700 that we had some user error with several years ago, and that forced us to buy the new Trilogy fancy one. And so we actually run every sample in both fluorometers, and they were both in agreement, and they were both very low.
How many samples do you take in the field? Can you do a standard deviation, or you
17.
17
So
that you're
one
averaging?
for each site, and then we're averaging those.
One for each site. Okay. So could you do 3 for each site so you can, or is that too much to remember? Just
That's a
because
lot of cost.
Yeah. So these are averaged over sites. So these numbers up here.
Yeah, so these numbers is going to be the average for the entire lake for that.
Gotcha.
And looking at the data for this one, we only had one that was above 20 micrograms.
Oh.
Everything was bottomed out in that 6 to 9.
So it'd be great if you could put error bars on those, just so we could see
Yeah.
some, and you'd be averaging over different sites, but still it would be.
Yeah, and we could probably do that, but for the most part, these are going to be fairly small.
Yeah, okay, cool.
But, yeah, we can look into
Thanks
that.
for getting into the weeds there.
Yeah, no problem. And that's one of those things where we kind of chalk it up to, okay, well, maybe it's a one-time thing, or it's a fairly quick rebound. But the thing that seems the most likely is some sort of nutrient limitation to the phytoplankton themselves, because it's not a grazing pressure response. It seems to be a pit carrying capacity and then population tanking response. Not really sure that's part of that uncertainty, as we don't fully understand nutrient cycling in the lake, whether that's south arm, north arm, DBL present, DBL absent.
Do you have phytoplankton microscopy counts for that?
Yes.
case? Okay.
Yes. So when we collect these samples, we collect 5 samples at 5 of the sites, 1 sample at 5 sites that then are looked at in microscopy. And the cells, there's not a shift in phytoplankton community. So it's still dominated by Denaliella, and the cell counts go down, but not this dramatically. So that's another odd thing where our cell counts aren't changing a whole lot, but our detected flow delay is.
You said drop to like 25%, and roughly
It's definitely smaller. It's not the 80% that we're
Okay.
seeing. So yeah, it's that a little closer.
I can't remember, Christine, do we have nitrogen data for 2021?
We should, yeah.
Yeah, because we could sort of plot that against the
Yeah, that would be
soluble
interesting.
nitrogen, just to see if there's a correlation.
That's something we just haven't had time
Yes.
with our schedules to
Yep.
connect on.
Mhm.
That was going to be an ask of us to get the overlays of this sort of.
Sure. Yeah.
The other thing to remember is the nutrient data is once a month at best. So a lot of times it averages out to about every 6 weeks. So if these are such a short, they can recover in 1 to 2 weeks, we may not be capturing that. And that's one of those things is maybe in 2014, 2017, maybe we miss how drastic the decline was. That speaks to all that uncertainty with just that.
Kyle, have you tried cross-plotting in physical parameters like climate, temperature, salinity,
We looked at all
just
of
to
that.
see if anything is
Yeah, there's no clear indication of anything, salinity, temperature, weather. Weather's hard because it's hard to get cold weather data. So that's why I like say solar exposure is an unknown.
Kyle, did that happen in 2022? I mean, I know it's
Yeah,
not exactly the same
Yeah,
pattern, but
and I purposely didn't highlight 2022 because there's so much going on in 2022 that it's hard to pin it down to just this decline and quick response. 2022 is highly variable, but this is all before we modified the berm in 2020. Because we didn't modify the berm until late summer, July. So we would have been dealing with higher salinity issues. We would have been dealing with similar or lower lake elevations than we have currently. But when you look at magnitude, amplitude, everything, when you think about salinity levels being closer to 180 grams per liter at that time versus the current 120-ish, I don't know that salinity is really going to be the driving factor because they're so decoupled, like, so separated in those 2 years specifically.
But the reason I'm asking is we do have 3 data points there that are really low.
Yes.
Which might, I mean, be interesting to see how the nitrogen overlaps.
Yeah. And that's kind of what we get to later in the talk with some of Gary's summarization.
So how active are the phytoplankton at this time of year? I mean, are they actively?
They seem to be the most active from the lab experiments that Gary's lab has been running. The cold temperature and the lack of grazing pressure is when they seem to do best. So they actually prefer the winter for whatever reason.
I actually have to put an asterisk here because if you're looking at chlorophyll, you're not looking at photosynthesis. So when we do carbon fixation experiments, and I've said this before, they're not doing photosynthesis because any kind of biochemistry proceeds more slowly when it's cold. So there is chlorophyll
There's
present.
chlorophyll present, but it may not be active.
Correct.
Perfect.
Correct.
Yeah.
They are not doing photosynthesis at the rate they would be when it's warm.
And that makes sense.
Right. So
But
they're
from
not
a-
fixing carbon.
But from a population standpoint,
Correct.
they are.
It's a good
They're
proxy.
growing.
Yeah.
better.
Yeah.
And that's the other thing is maybe this is setting off a warning bell that it shouldn't, because maybe this is not the metric to study. But this is data that we collect and have collected for a lot of years. And it's doing things that we don't expect it to do. And it's doing it to a higher degree this year relative to other years. So I think that's kind of where that came from. Then we're just looking at these individual years a little closer, so you can see that dip in 2015, where we dropped from the mid 50s to the mid 20s. Looking at the 2021 data, we're dropping from the 60s to the 15s, the mid teens. That's a pretty significant drop, and it remains there for a 2-week period. So sample collected, and then 2 weeks later, another sample collected, and it remained low. Looking at this 2026, I have 25 and 26 here because they almost look opposite. Where 2025 has it starts up, dips down, really gets shot up, and then starts to dip down. And the shrimp don't come in 2025 until more of that April timeframe. And then in 2026, which are going to be in the next couple graphs, where we're going to overlay some shrimp data over here, we see this really steep drop through December and January.
Kyle, if you guys tried to correlate this data with just things like precipitation patterns, snowpack, berm opening and closing,
We haven't had time. So that's kind of why we asked other people if they could have a little bit more time to look
Yeah, I
at
was
some of
thinking
this.
about Elliot's question. This question. What if we can look at session event on the lake, like elevation? Because you might see some. I mean, I'm looking at your data in January. That's when we have some of our strongest northwest winds.
Right.
And you get fetch setups and big session events.
Yeah, what if it just moves it off?
Yeah, exactly.
Yeah,
So
and that's
really
possible
nice
too,
to
but-
take your sample dates, plot them on the hydrographs from sulfur and see what's happening.
Yeah,
Some kind of things.
I'm open to.
Because that would basically tell you weather, right? You said weather is really difficult, and I think I totally agree. But maybe lake elevation, of course, really. That's those big funnel paths.
Yeah, we're definitely open to doing something like that.
Even, I mean, with that, just getting your kind of anoxic layer at the bottom stirred up, because I think previous research has seen this really stark changes in DO when you get after these big wind events stirring up kind of bottom anoxic down the bottom and one stuff. Even with the deep brine layer, there's, I think, some suggestion that if you get sulfur into the upper brine layer, they can consumes oxygen. So there's multiple mechanisms that could stir up those bottom sediments
Exactly.
and kind of have maybe a temporary dive.
You sent us the date, we could plot really quick on like, this is the date, look and see where it plots next to. Especially there's the.
I don't know if it's coincidence, but each of those 3 years happened after 2 to 3 consecutive years of the lake dropping.
Right.
So that winter is that low point. So it might just be a new set of microbialites that are exposed now and not contributing.
That's very possible. But this should be piped in the water. So this is taken, it's an integrated sample to 6 meters of depth. So we're not below 6 feet. You go to the bottom with about a 2-inch hose, tap the end of it, bring that back up, kind of homogenize it in the bucket, and then take a sample.
Just a quick note on this, Kyle. We sampled on the 13th of January.
Okay.
And our chlorophyll is at 85.
Yep.
So if it was a dip, it's a very short one.
It was very short this year because we did the same thing. Like I said, we got that 6. We were going back out on a shrimp only run. We weren't scheduled to collect any. And we took kind of a random sample, 4 or 5 of them. And we're right back to 65, 78. Where we would have expected.
Yeah,
to be.
that's curiously quick. But,
Yeah.
you know, on another note, in 2025, that midwinter dip without Artemia present, and we see that too. And
Yeah.
That's multiple dates. So it's a curiosity. We're not sure what to do, but
And so
it
it's,
makes a lot of sense.
and it could be all of these things, right? Because everything's going to have a little bit of your silk with anoxic layers. And that's why it's not maybe we have to do this right now. It's there's a lot we don't know.
Should we combine our data sets so that, because we don't always go out on the same date, so there might be some more there to look at.
We'd have to look into, for any of this, we'd have to look into data sharing agreements and some of that stuff.
Maybe we'd be okay with that.
Yeah. I think there's capacity there. We just.
Is your data not public?
It is, but it's protected, right? So it's we have an extra layer of some of it for the raw data. So we just have to talk to our administrators and make sure what the rules are.
For your data management? Okay.
I think we've done that in the past when you guys couldn't go out. You did.
Yeah, you shared some
your
data in
so-
2022.
But I mean, it's just an offer.
So when we overlay the shrimp numbers, because this is the other thing that we're out collecting is brine shrimp sampling. So these are total adults, or not total adults, this is total shrimp. So this includes nauplii. And most of these peaks are going to be driven by nauplii in 2025 and then again in 2026. And so I had to go back and actually look at the physical numbers because 60 shrimp per liter seemed like a lot, and it was accurate. We had a huge hatch this last year, 2025, and you can see this midwinter dip early in January, well before there was any sort of established recruitment or any sort of meaningful hatch coming. And then that persists into the late winter because we tend to see these oscillations, different generation peaks. And then they kind of graze it down, it rebounds, the shrimp rebounds, the chlorophyll rebounds, and they just kind of chase each other like we see through the summer months here in 25. And then as the shrimp start to be suppressed with temperature drops and that grazing pressure goes away, we see this rebound through November. And then we hit this curious decline in December, and there is a tiny bump. We get a little extra hatch because December was abnormally warm. But it's not enough grazing pressure to explain it all. And this is just going to be the continuation of this graph into 2026. So the green line is going to come down, contact with the bottom point, and that red line is going to extend up into that first little bump in January. And then we have our initial hatch, and I didn't have time to update the graph to current conditions, but we're starting to see more peaks that are going to be suppressive. Tripper action established. So it's a bit uncertain. And then for anybody that hasn't watched the tag meeting, I definitely recommend you go back and get the better version of this, where you can get everything that Gary says and all his caveats about not being a hydrologist. I'm going to do my best to summarize some of the key points of that. When we put the berm in place, it did its job and it blocked north to south flow. And that's what the little graph shows here in the bottom right hand corner. The flow from north to south functionally stopped for a very long time. And it's now slowly starting to come back with the erosion of the berm, sediment, things that the USGS is collecting some north to south flow on it. And there again, we don't understand enough of that because we don't have continuous monitoring for all the reasons we've talked about. Seeing this, Gary looked at some of the data, ran it through the ecosystem model that you built it for us, came up with some numbers, very general back of the envelope calculations. These are not hard numbers, but they get to the trend of without the berm, we get a state of equilibrium where there's about 2.5 times the concentration in the north arm that there is in the south arm. And that falls in line with what we measure with the nutrient samples in USGS. Since putting the berm in, that has shifted slightly because we're not seeing that north arm return. And it seems that the nitrogen pool in the south arm is starting to export into the north arm. Again, it falls in line with the observations. You know, the model's predicting 3.7, observations are about 3.9, which is pretty close. There again, I don't know how much stock you want to put in these hard numbers, but it really does kind of show that we are exporting nutrients and nitrogen to the north arm. At what rate, we're not sure. Like I say, the cycling in the south arm versus the cycling in the north arm is not well understood. Could be contributing to some of these issues. But it does show up in some of our data as we look at it a little closer to where we do see a bit of a suppression in the microbialite biomass and in the phytoplankton biomass, where we're starting to see that maybe numbers have come down, and then that we're also seeing that, what word do you want to put on this, but the chlorophyll content per cell, which is not something that we tracked explicitly. We didn't measure cell size. We do cell counts and we do chlorophyll count. And so what we're starting to see maybe a separation in what it once was in the high salinity years versus what it is now in the lower salinity years, where there's maybe not as many chloroplasts per cell.
What did Gary's data go back to on nitrogen imports? Like Lyndon, you got that graph showed that the berm. I apologize, I should have just gotten you back there. Maybe one more back.
There you go.
Okay.
Okay.
He goes back pretty far.
So yeah, he goes back pretty far. So the 97, and then there's that gap from 99 to 2020. They were all pretty similar. So he didn't really worry about including those because there was no statistical difference between 99 and 2020. So
So it's
it
not
just
a-
kind of shows that
it's not actually a data gap. You got
Nope.
the data.
the data's there. It's not a data gap and it's not a difference. So it's even from 97 to 22, there really wasn't a huge difference.
So like when we first put in the breach, wouldn't you think there would be a statistical difference or significant difference with that huge flux from the north to the south during that time period?
So
Or that you'd see it delayed even with the deep brine layer?
we didn't see it. It wasn't observed in that time frame in 2016. And the working theory or hypothesis, the idea is we had an established brine layer at that time that took a while to erode, which would have held more nutrients during that time frame because it was more similar to north arm water. And that slow release of that deep brine layer erosion could have offset that loss, because by the time we had that huge, 5 foot head difference south to north, and as that declined, and then we started getting north to south flow, that's about the same time frame that that.
You know, we can try to look a little bit at this ourselves, taking a slightly different approach using USGS total nitrogen. And if you look at the 10-year period before that breach was opened in 2016, and just correlate total nitrogen versus lake elevation, because it's a more conservative nutrient, it's kind of like salt. And then do the same for the period 2017 to 2023 when they stopped taking water samples. The two lines are in parallel, but a bit lower from each other, and the difference is that which correlates roughly with that. But I think it would be worth taking a deeper dive and potentially trying to do what is done with salt and maybe use volumetric means and try to estimate a total nitrogen mass in the south arm and see if that clears up some variation in that regression line. Maybe it makes it a little more clear.
I'll get,
Just another thing on your plate.
I did it. I already did it.
And that's kind of why we started this conversation. Is that we needed people with more capacity and like better expertise in this particular field, right? You have a question online?
Yeah, Bill has a question. Do the rapid January chlorophyll declines tend to follow relatively high chlorophyll in November, December?
I mean,
Does that make sense, what I'm asking? It seems like you've got a high chlorophyll A in the fall months preceding those big drops in January. And so I'm just wondering if like nitrogen's acting as a limiting nutrient and you're seeing that in that time series data.
yeah, and that's what we're wondering. Is
Okay.
if that's what the response is that the population reaches a maximum, there's no more available nitrogen, they die off, they decay within half a week, so 2-3 days, that nitrogen gets cycled, they're able to pick that back up with the few that aren't dead, pick that up and then bloom again. That's kind of the working idea, and that's the question that we're trying to ask.
Yeah, okay.
Because the fear is, what if that drop shifts, right? Because if that drop shifts out of January, when we don't expect to have brine shrimp, and shifts maybe more to February, March, when we are seeing more and more brine shrimp hatch in these warmer spring months. Are we going to lose the food source temporarily for the shrimp, and then they're going to hatch, and we're going to potentially mismatch that green up and potentially lose a crop of brine shrimp? That would be food for birds and also impact the industry.
Okay, thanks.
This presentation is asking more questions than it answers. Let's go with that. Another little caveat for us. So, based on all of this, running things through the model. So this is the nice part of where we have multiple lab experiments. We have kind of what we expect things to do based on lab experiments versus observed data. We run into this. If you just look at the nitrogen decline and assign it a 6% loss, and we run that out for a couple of years, we do expect to see some very large impacts on the shrimp numbers and the brine fly larva numbers, where those populations are going to be suppressed. The unique response to brine shrimp, and kind of this little caveat about the harvest industry and the cysts, when brine shrimp are stressed, they're more likely to produce cysts. That's what that shows, is that response of we observe a little bit more, maybe some more cyst production in times of stress, and that just gets amplified when you add in both the nitrogen decline and a salinity increase. So as we continue to go down in lake elevation and we potentially start increasing our salinity, right? We run into that issue. It just shows that it's going to be exacerbated with both effects. So
Kyle, Gary's model doesn't consider phosphorus, right? It's just nitrogen as a driver.
I think that's what he said.
I think, yeah, I don't think so. And then just the basic wrap ups of this is that the systems are linked. They both have a huge impact on one another, whether that's through salinity. It looks like there's some kind of nutrient connection, and we should have differential impacts, but we're definitely going to see negative impacts on the shrimp and the larva. Eventually, those are going to accumulate to where, you know, we may
So I just wanted to make a comment here, because I made that comment to Gary as well.
Yeah, you did.
Is the differential impacts are temporary. Because as your nitrogen declines, ultimately you get an oligotrophic system, and you won't have a lot of brine shrimp, and you won't have a lot of system.
No, correct. Yeah, and so it doesn't matter that your cyst per shrimp increases when you're increasing flow numbers.
Certainly no benefit to the industry. If there is a benefit, it's temporary.
It's a temporary benefit, and it should serve as a warning sign. And then Gary included just a little commercial, it's not nice to Mother Nature if we go.
I like that commercial.
Okay, we can try it.
There's no sound.
Oh, sound is important.
Yeah.
Yeah.
I'm just excited that Gary's progressed beyond the Comic Sans font to videos embedded.
That's pretty much all I had.
Still got that. Still got it.
So I guess to summarize is we're observing a decline in nitrogen concentrations in the south arm. We're seeing a response from that in the phytoplankton. We're seeing, and then we're seeing what the model would predict would happen with a decline in nitrogen is where we would see an increase in brine shrimp cysts initially because the brine shrimp are stressed. But then we would see a decline in the brine shrimp and then also with brine flies.
Yeah.
And that's the concern,
That's the concern.
is that if this trend of 6 what does that mean? And the model doesn't, it's not good. And so that's where we want to, why you're it appears that the berm, while it has cut off the north arm flow and the salt load as intended, and it's functioning very well from salinity standpoint, it appears there might be an unintended consequence is that it's also blocking off the nitrogen look the south arm. So I guess with that, ended up to see.
Cool. So now we're going to get into the nitty gritty of nutrients. And I was excited about this, and then I quickly got overwhelmed. So bear with me. I'm going to show you a lot of data, and please jump in as we go, ask questions, ask for clarification, because it's a lot to kind of introduce this new set of constituents to what we're already thinking about salt. So as Kyle sort of outlined, nutrients are kind of the foundation of the ecosystem in the South Arm, even in our brine shrimp and brine fly food webs. And nutrients are cycled differently than salts. They're biologically active, they are chemically reactive, and they also respond to hydrology like salt does. So there's many processes happening that would affect nitrogen or phosphorus concentration at any time. So I think it's important to keep this complexity in mind. And also keep in mind, there's a lot that we don't understand about these cycling processes that are actively, always active in the time. And I wanted to just give this group just an overview of the nutrient monitoring program that we run in collaboration with the Great Salt Lake Ecosystem Program. So we DSLEP collects water samples monthly at 4 sites in the South Arm. These are also the same samples where we measure salinity from. We also monitor the nutrient inflows coming in from our major surface water inflows on the Bear, the Weber, the Farmington Bay outflow and at Goggin Drain, and also monitor the exchange at the causeway breaches, at the new breach and at Lakeside. So you have some idea of the data that we're working with. These data go back to about 2010 for inflows and for the South Arm monitoring. And for nutrients, there's many to consider. It's not just like for salinity, we have one. For nutrients, we have many. For nitrogen, we're looking at both total and dissolved forms of nitrogen, including inorganic forms of ammonia, nitrate, and nitrite. And for phosphorus, we deal with total, which is a raw form, dissolved phosphorus, and phosphate. And so just to give you kind of an idea, orient you to the kind of ranges of concentrations we see in the South Arm. On the left, I've plotted total dissolved nitrogen from 2010 to present. On the right is total dissolved phosphorus. And just to give you kind of ballpark for the upper brine, those are shown in kind of the light blue. These colors are color coded by depth. So for the light bluish colors, that's representative of our upper brine layer concentrations. And then these darker purples are indicative of when we have a deep brine layer present. And it's really important to keep this in mind. So when we have a deep brine layer present, nutrients tend to be what I guess we could say sequestered in that layer. They're much higher concentrations. And along with that, we see decreased concentrations in the upper brine layer. So when the deep brine layer is present, what's available to the biota in the upper brine layer, that concentration goes down. So that's a kind of an important feature that I think is important to keep in mind. Because the concentrations we've observed recently in terms of nitrogen are not unique. We've observed these in the past, especially when the deep brine layer has been cooked. And just to give you, you don't need to go into a lot of this, but to just show you kind of the magnitude of the data we're collecting, all these different species, and it's quite complex. And when we think about what's being taken up by phytoplankton, it's really these inorganic species of nutrients: ammonia, nitrate, nitrite, and phosphate. So this is what's most bioavailable. Also, what's most difficult to measure. Many of these are below the detection limit, often because they're being taken up actively. But just to keep in mind, a lot of the analyses we do for looking at nutrients are really focused on these total forms. And in this case, the subsequent analyses I will show you will focus on total dissolved nitrogen. And nitrogen is thought to be the limiting nutrient in the South Arm. That's based on, I think, bioassays from the 70s, probably other studies as well. But to my knowledge, there hasn't been kind of a recent look at nutrient limitation. For the purposes of this analysis, we'll be focusing on total fullness. And just to give you some context, Hannah McElvin in our office did an analysis of kind of a nutrient mass balance for the South Arm. This plot is showing sources of nutrients to the South Arm. So where is the South Arm getting all of its nitrogen and phosphorus from? So values above 0 are indicative of what's coming into the lake. So nutrient imports, those are from and we considered major surface water inflows, so Goggin, Weber, Bearberg, Farmington Bay, and then also what's coming in from the new breach, so south to north flow. That's shown in purple.
Can I ask a quick question about total dissolved nitrogen? So that's including ammonia, nitrites, and nitrates.
And dissolved organic.
Altogether. Okay.
Yep. So in this plot, what I want us to focus on is the period 2017 to 2021. So this would be the period when the new breach was open for about 5 years, and we did this mass balance. And during this time, the greatest source of nutrients to the South Arm was the new breach and that flow that's coming from south to north. And these numbers at the top of these kind of bar plots show the fraction of input nitrogen coming in. So, for example, in 2020 and 2021, we estimate 62% of the dissolved nitrogen coming into the South Arm was from the new breach north to south flow. So it's a significant source of nitrogen to the South Arm, in addition to the kind of the sum of all the other inflows. And during this time, we saw a net gain in nitrogen mass if we consider these inflows and outputs. We were seeing a net gain during that time. Here, though, is a volume-weighted dissolved nitrogen concentration. So this is considering the full water column, and this is, for those of you familiar with how the methodology we developed for salinity, I've applied the same method to our total dissolved nitrogen concentration. So this is shown from 2010 to present, and these lines denote when the berm was modified in July 2022, and then in February 2023. And here's kind of the concentrations we're seeing now. One thing to really keep in mind is that it's much more variable. Nutrients are harder to measure. They're more labile, they're more active, so they really just are more variable constituent in the system. It's not as clean as salinity data.
Quick question. So are you filtering out the cells before you determine the nitrogen, or does it include the cellular nitrogen?
So our dissolved nitrogen are filtered at 0.45.
Like 4 or 5. Okay, so some microbes are going to get through, but that's pretty good bacteria. Okay. You're filtering out algae, but maybe not some cyanins.
And I did just a statistical comparison between the period before the berm was modified and after, trying to get bracketing the same number of samples on each side. And there is a statistically lower concentration we're observing now, around 4 milligrams per liter, relative to the time immediately before berm modification, from about 2020 to 2022. However, it's important to keep in mind that these concentrations you see now are not unique. They've been observed previously. And even kind of in 2011, 2012, concentrations were even lower. If we look at the mass, so no longer looking at concentration, we're looking at mass. The order of mass we see for total nitrogen is on the order of 30 to 35,000 tons of nitrogen. And we do see, pretty consistent, stable mass prior to berm modification. And I believe we did a trend analysis as part of Hannah's analysis, and there was no statistically significant trend up to 2021. If I compare the masses after berm modification to before berm modification, we're seeing a statistically significant decrease of around 3,000 tons. So the nitrogen mass appears to be going down in the South Arm. All right, so that was really focused on South Arm data. And now I'm going to focus us on what we measure at the breach. So Andy measures discharge monthly, and then we collect water samples monthly through the runoff season and every other month during non-runoff season. So we have a nice data set to work with here. And huge thanks to Scott for putting these fluxes together for the breach. And so here we're looking at total dissolved nitrogen for south to north flows in green, and then north to south. So first thing, the take home here is that the north to south concentrations of total dissolved nitrogen are higher. On average, they're around 7 milligrams per liter, whereas our south to north is around 4 milligrams per liter. And from some of Scott's exploration of ratios of nitrogen to salt and ratios of nitrogen to other nutrient species, it appears that the concentrations in the North Arm are not a function of purely of evapoconcentration. If it were just evapoconcentration occurring in the North Arm, we'd expect these total dissolved nitrogen concentrations to be higher. So there appears to be some evidence that nitrogen is being sequestered in the North Arm, even though it might be fixed. It appears that there's some amount of nitrogen being fixed in there. Bottom line is, when we put nitrogen in the North Arm, we're not always getting it all back. It's just important to keep that in mind. And that's really illustrated by the flux rates. So here now we're looking at flux of total dissolved nitrogen in tons per day at the breach for south to north in green again, and north to south in red. And for the period prior to berm modification, right about here, I'll just these are there. We really do tend to see, and these are discrete measurements, so we're not interpolating anything in between the periods where we have measurements. It appears that we do have a net export from south to north of nutrients most of the time, even without berm modification. And certainly after the berm was modified, we saw fluxes coming in from the north. They went to zero, as you might expect. We just cut off the discharge. And so there's been a huge amount of export happening from south to north post berm modification. And Scott estimates that we would be getting, that's about a 2,000 ton per year reduction in what we're getting from the north. We look at that a slightly different way. I just kind of summarize the distributions of those calculations. For dissolved nitrogen, this is our net nutrient flux in tons per day, with a positive value being an export. So pre-berm is in this kind of bluish color, and post-berm is in this salmon color. So we have more export, as you might expect, happening right now after berm modification. And if we compare this, and I just want to highlight, these are using distributions, medians of distributions, because the precision of these measurements is so much lower. So the uncertainty in this is greater, okay? But comparing these two median values in response to berm modification, we estimate about a 1,200 ton per year reduction, and what we're sending 1,200 tons per year more to the South Arm now than we were pre-berm modification. And per year, that would result in a total dissolved nitrogen decrease of an estimated 0.14 to 0.21 milligrams per liter nitrogen reduction in the South Arm. And that's just assuming some volume, that we've observed recently. So gives you some idea of the magnitude of concentration change that might have happened per year in response to what happened at the breach specifically, the mass flux changes that happened at the breach specifically. Another way to look at this, which was suggested in one of the tag meetings, is that what would happen if we were to dial in the new breach and say we get 0 salt flux happening at the breach? What would that do to nitrogen or phosphorus flux? And so I did this calculation, and I'm happy to go through the details if anyone is interested, but I assume you're not. But the take-home message is that if we were to arrange the breach so that we're getting basically a net 0 salt flux exchange, you get greater nitrogen export pretty much all the time. So it's just kind of seems to be what's happening at the breach, is that we export nitrogen.
It'd be interesting to look at not just the export of nitrogen, but also the import to see if the balance is in it. What the balance
This is the net. This is
net,
the net.
including the import.
Yes.
I mean, import from other
North
sources. No.
Yes.
From
we can do that.
river-
Yeah.
river
Exactly. No, that's
imports.
very, very important. So yeah, this is just net at the breach. The imports from the rivers are very important for kind of tipping the balance to any kind of net gain in the good try. I mean, we can. That's quite an intensive analysis, but yeah, we can.
And then I had another question, Christine, and I don't know what the answer is, but maybe should we be looking at dissolved nitrogen, total nitrogen, or both? Because when we look at dissolved nitrogen, there may be much more dynamics going on and much more fluctuation. When we look at total nitrogen, that may be a little bit more stable.
Yeah.
I don't know. I don't know what the answer is.
Yeah,
I
it's
think
a
we
good
might have
question.
to look at both.
I agree. Yeah, I think, no, that's exactly right. And that's why I said, hey, we're looking at kind of one piece of this puzzle, keeping all the other options open in our minds. But we have confidence in these total dissolved nitrogen measurements. And honestly, the total nitrogen measurements we're getting now from Chesapeake Biological Lab are a little troubling. They're just a little bit greater differences than we would see at our National Water Quality USGS lab. And so for this analysis, we really decided to go with what the constituent we had a lot of confidence in touch that I think you're kind of as well figured, but getting at the totals might be a more complex. And the dissolved nitrogen also kind of gets us closer to inorganic. Whereas the raw and whole fraction, you're kind of dealing with particulates that are available better.
So you've got really pretty good agreement then between the National Water Quality Lab and Chesapeake on the EDN.
We're getting decent.
Okay.
Not great. It is, I think Chesapeake Biological Lab is a little bit lower, if I recall. But it's certainly better than the total.
Okay, so maybe it becomes more clear. There might be some slight adjustment in this calculation
Yes.
since one lab is after and the other one's before.
Correct. And that is a confounding variable in all of this, which is why I tried to be clear about the labs we're using, because that is a confounding variable.
That's really interesting.
All right, so I'll just kind of wrap up this set of analyses. We're seeing a statistically significant decrease in the total dissolved nitrogen mass in the South Arm after the berm was modified. We're also seeing decreased flux from north to south at the new breach. So, and those estimates from both of those changes seem to be in pretty good agreement. The magnitude of change seems to be in agreement from those two independent. Oh, right. And then I did develop isomax flux for dissolved nitrogen in the full water column. And I don't know the utility of this, but since it's been a helpful framework for salinity, I thought I would just try it out. So we have South Arm elevation on the y-axis, volume weighted total dissolved nitrogen concentrations on the x-axis. And this is the full water column. So in periods where we have a deep brine layer, this is not representative of what's actually available to the biota. But this is just an example of what this might look like. Our most recent measurements are on January 14th of this year. and we were getting about 3.9 milligrams per liter nitrogen, 27,000 tons. I think it is interesting to, okay, right. And then I wanted to show, this is the blue dot where we are. And if we kind of just look at the distribution of concentrations where we've been, kind of middle of the road of previous observation. In terms of mass, we're kind of on this lower end. We kind of put lines perpendicular to our isomass lines. We're kind of at the lowish end of mass, and then certainly of elevation. I think it's important to actually look at the upper brine layer in addition to that. So this is representative of what's available to the biota, to the phytoplankton, and then subsequently the brine shrimp. So if we just consider the upper brine layer volume weighted total dissolved nitrogen estimates, this is what that would look like. So the masses are different, obviously, because we're just looking at the upper brine. And the first thing I want to point out is kind of how I arrange these colors. So the purple, this is light purple is when the culverts were open and we had a deep brine layer present. The dark colors are also when we had a deep brine layer but under a new breach paradigm. Those tend to be lower. So these upper brine layer total dissolved nitrogen concentrations, when we have a deep brine layer present, tend to be lower concentration. And then these kind of green colored dots represent when there is no deep brine layer. So we have that nitrogen at depth that's being mixed into the water column, and that increases the concentration. So looking at this upper brine layer dissolved nitrogen, we're kind of middle of the range for the mass and in that section of the water column, and low range of middle of the range of concentration and mass. And then I also considered ammonia. So this might be more interesting. Ammonia, that's what we might think of. We can measure this way better than we can nitrate and nitrite. This is what might be available, is available to the phytoplankton directly. And we're seeing pretty low concentrations of ammonia, of volume-weighted upper brine layer ammonia, and low masses relative to what we've observed in the past. So this is just an initial effort to try and put what we're observing now into the context of this about 15-year data set.
You're saying like chemical destratification, you're pretty much consistent with nitrogen when it's not stratified. No deep brine layer. Things are pretty much how.
Correct. When we haven't observed the deep brine layer, the concentrations we see now are similar to that, if not a little bit higher than we see a full. Sorry, when we have a deep brine layer present, we're seeing concentrations now that have been higher than the upper brine layer when there was PBL. When we have it all mixed in, the concentrations tend to be higher than these.
Yeah. Trying to think of like the feedback mechanism without chemical stratification and what that is for phytoplankton.
Right.
And that seasonal change.
So you're thinking about if we were to open the berm, get a deep, get north arm flow, and you form a deep brine there, how long might that lag be before you see that in the
Right, and then that's just the part of the turnover for the population. Is phytoplankton natural.
I mean, my big
course, it's
saying
not
is, for the deep brine layer disappears in what, if we want to do. Brine layer disappears, maybe. I mean, the nutrients, it's difficult because you have cycling of nutrients.
Yes.
Also need them in those.
And yes,
And oxide.
and there's so much we don't know about, if I can say, the function of the deep brine layer and facilitating release of nutrients from the sediment. And so it could be that the deep brine layer presence is actually a way of getting nutrients out of the sediment and subsequently releasing. But I think when we think about mixing the back in of nutrients from the deep brine layer, we also need to think about lake elevation because we're getting really shallow and with wind action.
The shallower it is, the more
Yes.
destratification.
And we
So more
actually saw the deep brine layer disappear when we still had the breach open due
Right.
to our hypothesis is that. But this was like in 2022.
The contribution of or not of the microbialites as the lake, decreases of lake level.
Mhm. Right, if they come offline. Yeah, exactly. Different processes coming out and out.
But I still wonder if we should still look at total nitrogen when we're looking at, sort of the net loss or net gain. Because long term, I think total nitrogen is going to be important than looking at net loss and net gain.
I can do that both for South Arm and Red Beach.
I think the isomass curves are gonna be, at least the ones that Phil created were called. There were two distinct different curves. But again, with a lot of variability, which you're seeing also, but maybe with less variability than looking at just the soil.
Okay, so Phil was using total.
He was using code.
Okay.
But I agree with you. I mean, the dissolved nitrogen is what's important. Sort of to look at the immediate effect, the long-term effect. I think people might choose to look at.
That's a good way. That's kind of all I had, Jeff, for the nutrient stuff.
Oh, so one of your plots where you looked at, total dissolved nitrogen since like 2012 when the culverts were closed.
Okay.
No,
For the
that's-
isomass?
the concentrations. Yeah, I guess when we had low total dissolved nitrogen concentrations when the culverts were closed, which would be, I guess, an analog for where we shut off the north to south flow. So I guess
Exactly, yeah. Yeah, I've been really curious about kind of looking at the phytoplankton data we have from those previous time periods and seeing if there's a response in the phytoplankton to be slower.
Right.
And I think that's why, we identified 2015. We saw that same kind of response in the midwinter troughs.
Looks like the 2015 concentrations were similar, if not a little higher than.
So I guess the good news is opening up the breach, brought nitrogen back online and systems that are doing fine. But something that I wondered if it was worth looking into more.
Short term, it was a net benefit. I mean, for the upper brine data. Long term, there's a risk, and that's what I think we need to assess.
I don't want to derail the berm conversation, so I'll put an asterisk in this, but, I mean, who is processing the nitrogen are the microbes, and, it's not just, cyanobacteria. That's the old ecology model, but we know that archaea, methanogens that make methane are processing. There's ammonia oxidizing archaea. We know that they're also cycling. So there's some heterotrophs that aren't being powered by the sun that are also cycling nitrogen, and we have evidence of them from the tar seeds to the North Arm water to the sediment, as well as in the water column of the South Arm. And we also know that cyanobacteria are, also, of course, very involved, and they're in the water column. So when you talk about phytoplankton, I'm assuming you're talking about large algae and not cyanos. And you are filtering out Denaliella, et cetera, and the other algae that are in the South Arm, but they aren't fixing nitrogen anyway. The cyanos and the archaea would be the fixing, and they are going through your filter. So the question is about how much biological nitrogen you're getting in your samples. And I would love to, we use a 0.22 filter as well as a 0.46. So it would be really interesting experiment. And again, just an asterisk, we don't need to derail the conversation, but to send a sample that was filtered with the smaller filter, send a sample that was filtered the way you do it, and then send a sample that wasn't filtered to see how much is a biological component of the nitrogen measurements.
Yeah. Do you think that, because I tend to think of the organic nitrogen as the difference between inorganic nitrogen and the dissolved nitrogen. So is that kind of what you're getting at?
So they're excreting it and trading metabolites. So you don't know what's inside a cell and what's outside of a cell. So it might be biologically available, but being sequestered in a granule that is associated with the cell membrane inside, or it might be being released by a cell. And so it's very complicated, nitrogen metabolism in microbes. And so the question is, you know, I'm so excited that we're finally on this committee talking about microbial metabolism. Now, I've been waiting my whole life for this. And the validity of the microbes in the North Arm. Anyway, I think that would be a really easy experiment. If you want to do that sometime, let's do it. So, okay, cool.
Awesome. Thank you. Bill.
Yeah, just to add to that, you know, the cell sizes are in that range of those cutoff filters. So what Bonnie's saying makes a lot of sense. You should play with those a bit to see how that changes the concentrations. What I wanted to point out is that, you know, the berms may not be our only tool here. You know, what has anybody been looking at the possibility of changing the nutrient influxes using the wastewater treatment plants and their treatment technologies?
Yeah, we can look at the effluent. It has to meet EPA if that's still good. So that's the
In terms of how much nitrogen is coming in.
yeah.
Yeah, and I'm asking that question completely out of the bounds of regulation, right? Just understanding whether or not that's even a potential knob.
Right. Well, I think it's a good question, and I don't know that we have the answer here. I think, Jim, I don't know.
I'll just say within the bounds of regulation, it's not necessarily feasible unless you replace all of it. Taking it, you know, allowing it to discharge into the receiving waters would not be it. But in the case of North Davis, for instance, you would pipe it directly. Sure. Without that, we give them an offer from technology they set with them to do that. It depends on the context of what you're talking about. But you look at some of the graphs, excuse me, and just looking at the magnitude of what's coming into the rivers versus the North Arm, and the rivers include so much more that nutrient sources from other things other than wastewater. This is a rough.
Absolutely.
Gee, would it be worth looking at seasonal discharges of nutrients? There are periods of time where we get high runoff and high inflow. We would allow more nutrient discharge from periods of time we have low runoff as a tool to potentially bring nitrogen into the lake, were that necessary.
Yeah, I mean, you'd have to look at that and see what effect it has on the nutrient pool within a river system and how much of it get cycled into the river and causes effects that we may not want to.
You'd have to look at it, but I mean, would it make sense to at least look into that as a potential tool? You get this huge runoff.
I look at systems like the Orphan River. They have Washington. If you're adding more treated wastewater to it, it's just that's great. It's an experiment. I'm not sure. It was a difficult to answer that question.
We can definitely do that. Our gauges for our main surface water gauges, we can look at that, and you would expect higher loads, certainly periods of runoff when discharge is higher. But the relationship between nutrients and discharge is something I know. Is it actually concentration going up as we flushing, or is it diluted? And we proposed in our GSLUC agreement for next year to quantum update the inflow loads. And we can look at it.
Yeah, that would be a first approach.
Point out that we don't regulate nitrogen. We do regulate phosphorus. Just keep in mind boundaries. If we regulate ammonia for toxicity, so we don't want to kill, in which case we probably continue to do that, regardless of when we discharge it. So we're not really putting limits on.
So the results of putting limits on phosphorus.
Hi, archaic.
Yeah.
Everybody else.
I think
Just comforts.
Jim, to
summarize that as, I mean, you're, from a regulatory standpoint, you're protecting the receiving water body.
Right.
And so, there's a lot that happens in the receiving water body and then as that water travels through the lake. And so if the Jordan River was a pipe, that'd be different than given that it has its own ecology. So,
One final remark on that. I'm sorry.
go ahead.
So we have some new gauges that are closer to the lake on the Weaver River, a new gauge on Lee Creek. So, especially the Weaver River, I would think it would be important to sample those lower gauges now, the North Fork, the South Fork, that are closer to the lake to see how the concentrations of nutrients at those two sites compared to the Plain City gauge.
And how those concentrations correlate with, the runoff theory.
Yeah.
I think would be very interesting. It would be a first approach in looking at potentially using that as a technique to manage nitrogen inflows into the lake.
I know when we sampled the North Davis Delta at the old discharge, and their nutrients were down to background levels after it ran through 1,200 acres of wetlands before it got to Farmington Bay. So, I mean, Farmington Bay is a small part of your overall budget, but with the lower lake, with all the wetlands in between, those wetlands are cycling back nutrients too. And consume.
Yeah.
So let's look at options.
Okay,
Scenarios.
all of it taken with a grain of salt. How much salt?
That is what we do on this committee. We take everything.
I'd like to make a couple comments, Jeff. I think before we look at options, I think we need to look at overall balance. I think we need to look at nitrogen inflow through rivers and see how that may or may not balance the net losses we had through the breach. And I think that's a really important mechanism that we need to look at in terms of the total nitrogen budget. The other thing I believe we need to do is also look at total nitrogen, because I think at long term, the total nitrogen may be more important, where short term, I would totally agree that totally dissolved nitrogen may be much more significant. I don't think we can make a lot of recommendations before we have that data set, but that's my opinion.
Well, I think just
Leave it at that.
real quick on that same regard, Dallas, because it does seem like maybe we need to wait until the next SAC meeting recommendation, but we should try to line out at least like what information we want to have ready before then. But one thing I think we do need to consider is, just in general, thinking through nitrogen, not even considering nitrogen, but also while considering nitrogen, what we may want to do like this fall. Like they have the special session. I think there's some expectations that we're looking at, more than just salinity now. We're also trying to manage for quite a few other specific proofs, as it relates to berm. And so, if the expectation is that, we want to protect these other functions of the lake, like one would be like, if we think we're going to have another bad year, we're going to go much further below 4192. We know we're going to expose as much microbialites. Maybe the move is that, in November we raise it up and try to get down, when you're so prepared for that, we would want to consider importing a bunch of salt, but we could also potentially import a bunch of nutrients at the same time.
Mhm.
So I think we just, I think we got to think through this a little bit, like what the next 18 months is going to look like.
Well, and I think the good news is that we could even, for a little while longer, just manage on salinity, because we know that we got an increase in dissolved nitrogen due to the loss of the nutrient layer. So we are sort of in a situation right now where the total dissolved nitrogen is actually higher than it was historically. Now, that's potentially a temporary
Pretty
situation.
sweet science experiment too, to even lower it and see what happens as we measure what flux is back to the south arm. Just looking at the
I'd sign up.
nitrogen mass. Yeah.
This is a really nice plot to show like we're actually maybe not being a critical point yet, but it's good to have these conversations ahead.
Sure.
So
Yeah, and maybe just that, 4 months isn't a lot of time to, we're going to open it up and say, let's run to the end of the low point of the year, which is usually like in October, early November. You know, if we ran through that, that's not a lot of time to have to breach lower. And I think that this is something I think we've all talked about either separately or on one-offs on what we should do, but I think the concept right now is maybe we should bring back a little bit of salt in preparation for wanting to, you know, raise it to keep some other functionality on the south arm going for that limited amount of time we have with the, you know, what the laws allow us to do with the berm. But again, this is where I think this conversation probably needs to be more robust in the next, 23 minutes. So
Right, do we,
I was just gonna say the flies as well as the shrimp had a robust year last year. Like this would be a great year to play with this,
yeah,
you know, because
and
the
like,
populations are.
and try to maintain that, right? Like we can, you know, we'll buy off one extra year while we're doing extra things, right? Like,
Right.
there's all these different efforts happening in water to the lake. So if we can like Band-Aid fix a couple things while we're trying to work on these broader, more systemic issues, you know, like that, I think it's worth
And
trying
if we
to.
could do some additional experiments during that time to
Mhm.
drill into the nitrogen and so.
let's go to Bill, and then I think
Go Bill.
her scenarios bracket things really nicely, and give us some idea of what happens if we block things up or if we open things up, and is there a response?
We try to keep like 10 minutes for homework assignments.
Yes.
So we know
Oh,
that
yeah.
next time we come, we all have things that need to be there for decisions.
Bill,
Yeah, just a real quick, if we're getting more serious about a mass balance on these nutrients across the lake, a lot of it's going to come down to increased sampling and monitoring at the inflows, presumably by USGS. And I don't know where we are compared to back in the day when we beefed that up in the Selenium project, but you know that's a significant budgetary piece. And so I just want to put that as a placeholder that it's not as simple as it's going to take some real increased monitoring and event-based monitoring. The problem is that as the river inflow increases, you tend to flush things much more than on the tailing limb of the discharge curve. And so it's also an event-based kind of monitoring too, as well as regular monitoring.
Bill, I can speak to that. USGS monitors the inflows, major surface water inflows every 6 weeks. So we get about 8 to 9 samples per year, and we do try to hit high flows. That's part of our monitoring routine. It's to try and capture high flows, really low flows, trying to capture a range of hydrologic conditions.
No, and that's great. That lets you correlate things on Loadest or whatever software you use to create these correlations for things that aren't being monitored. But also on the rising versus the falling limb, even though you get the same discharge on either side of that limb, the concentrations can be quite different. So there's an event-based piece to this that also has to fall into place in addition to just doing this across a bunch of different discharges.
Yeah.
Just have a question for Christine before we look at what next. Is there a way with the current information that we have and the modeling that is available to us that we could create a preliminary model where what would happen if we open up the berm, let's say when where do you think?
Oh, I mean,
6
honestly, I
weeks
think
from
the
now, 8
benefit-
weeks from
the
now?
longer we wait, the smaller the benefit.
Yeah,
that's exactly what
exactly.
Christine's getting at, is what if we
Okay.
open it now, what if we
Yeah.
open it later, what if we close it?
Okay,
So those are the things that I tried to bracket.
Well, yeah, and then we can kind of build that out more. So yes, Jeff asked me to come up with a few scenarios to kind of build on what we shared previously. I'm just gonna, you know how I try to do this. The fall predictions for fall using the mass balance approach for dry, warm conditions, 134 grams per liter for salinity, and for average conditions, 125. I am really not satisfied with this approach, so I did another one. Which is basically to say we're getting an average of around 2.7 feet decline during what I call the evaporation season. You can also call it season of net water loss. And then I take kind of a 95th percentile kind of confidence interval to just look at a range of declines. Just if we remove that water over the season, getting a range of elevations ranging from 4189.9 to 4189.4. And those would result in fall concentrations that are a little bit higher than the other method, 138 to 143 grams per liter. And that's kind of the starting condition is the low April 7th measurements of salinity that we measured. So ballpark fall salinity. So then walking through a few scenarios of what we might expect 6 to 12 to 18 months into the future. Okay. The first scenario is, and I did June 1st. I know that's probably aggressive, but to get at this, 5 months of change. Lower berm on June 1st, and that I'm assuming would mimic what we had the cross section we had previously. So that allows me to look into historic data when the breach was open and try to look at flux and discharge rates that were measured previously. So lower the berm on June 1st, import salts and nutrients and whatever else from the North Farm during summer of 2026, and then raise it on November 1st, 2026. And and all of these we raise it, and I'm assuming that just basically disconnects the North and South. I know that that's oversimplifying it, but it's very hard to predict what fluxes might be at a range of berm heights, and I didn't want to go there. So scenario 2, we lower the berm on June 1st, 2026 through January 2027. So we would raise the berm on February 1st of 2027. So just extending the period in which the breach is open. And then scenario 3 is we don't modify the berm over the summer, but we still raise it on November 1st. And please feel free to jump in if you have questions at any time. So now we're looking at this isomass plots of salinity. These are all going to be at salinity. This is our measured values on May 20th, 2026. So this is kind of where we are roughly right now. 118 grams per liter, 4191.9 feet, and 847 million tons of salt. So going into the fall, predictions on November 1st. I assume that we're going to drop 3 feet. So you're all aware that's the assumption made here. And so that gets us to an elevation of 4189.3 feet with the two scenarios we have. First one, scenarios 1 and 2 with the berm open over the summer, estimating that we get, I think it's 32 million tons over the summer that we import. That would get us to 879 million tons of salt by the fall. Scenario 1 and 2 are the same for this time step. If we leave the berm open, we continue to lose salt on the order of, I think it's around 14 million tons for this 5-month time period, and you get 835 million tons. So you get these kind of salt masses change for these two scenarios. For the scenario as is, I estimate about 140 grams per liter, and then for the modified berm, 147 grams per liter. So a little bit of an increase for the scenario where we open the berm. Fast forward, okay, and then for nitrogen, very, very coarse estimates of what this would do to nitrogen. But for the instances where we leave the breach open, if we open it, we would import an estimated 570 tons. And those are based on very crude kind of median flux rates we've observed in the past. Relative to the resident salt or nitrogen mass in the South Arm, that would be about a 0.1 milligram per liter increase. That is not measurable. That is within, the uncertainty of what we can measure with our methods. So we should not be able to plan to measure that, but
Is that a net import?
yes, net import. Yes, net import of nitrogen. And then for the kind of as is scenario, we would lose about the same amount, 500 tons of total nitrogen over this roughly 5-month time period. Just to use. All right. So if we fast forward to May, all right, and then again on November 1st, we raise the berm for scenarios 1 and 3. So cutting off the I'm sorry, I know this is a lot.
You can take a breath.
That's great.
That's a lot.
Okay, it gets even more complicated. So May 30th, 2027, about 12 months from now, I considered 3 elevations. This is the most difficult kind of period to guess what, the lake will do. It's all about water volumes. So we've got a scenario where we repeat 2026 runoff and gain about 1.3 feet. That's this low horizontal line. Mean runoff is about 2.2 feet of rise. That's kind of this middle range. And then 2023, just as a high end. So that represents our wet, average, and dry warm scenarios. And then associated salt masses with each of these scenarios. So I want to point out for the second scenario where we raise it on February 1st, we lose mass, salt and nutrient mass. And that's because we have a season of net import of constituents from the North Arm. That's roughly from June to October. And November, December, January, you start to have net export of those things at the new breach. So it's from the analysis that I've done, it's not advantageous to leave it open longer than October. There's a point in time based on the elevation differences between the North and South Arm where you can import things from the North, net imports. But after the lake starts to rise, the south arm starts to rise, you then get into kind of a net export paradigm. Let's see. So we kind of just walk through some of these ranges we observe for the very wet condition. You're getting into salinities around 100 grams per liter, average around 120 grams per liter, and for dry warm around 130 grams per liter. There's not a ton of difference in salinity, around 5 grams per liter in each of these scenarios. It's really driven by water volume and what we can expect in terms of a wet or a dry year. So that's, yeah. Anyone, any
I
questions?
think either scenario, I don't see a high risk for the brine shrimp population. I think we could just sit here
Nor the flies.
and know the flies and check what we think would be the most useful as an experiment. I think that's what we were indicating. that.
I'm just trying to, yeah.
Well, that's one experiment that I don't think we've ever done is we've never tried to lower the bridge.
No.
So
I mean, it's done it naturally.
but like we haven't actually tried to go in and modify it down.
Yeah.
And which then square. it.
Presents like other issues, construction issues, removing the giant boulders that we placed and things. I mean, they're pretty large and it's gonna be hard to get to the center of the berm with a long arm and other things, but I think it's doable. It's just different than putting rocks in. You kind of build your way out. I have a question about timing. So just as you said about, raising it, in February versus like November, once the lake starts to, inflow start to come in, that benefit kind of goes away. We actually have a loss. It would seem to be like right now is we kind of have that head difference. The benefit's not going to be realized until really later in the summer when those things equalize out. Am I mischaracterizing that? Like it's not as urgent as like, let's do this tomorrow, or is
Good
it?
question. What is it, Ryan? A 0.9 foot head difference right now?
Yeah, 0.9, 0.8.
It's still about, I mean, this would be a question for some, because even though there's a head difference, what's the pressure differential? It's really not a ton of a head differential, especially for springtime.
Yeah.
And the fact is we have seen net import during previous June. And so from what I've looked at previously, as soon as the south arm kind of stops increasing and then you're still getting flow into the north, you get a good drive from the north to the south. It really starts to equalize.
Okay. And then another thing I just wanted to post to the group, because I think that we have a little bit of extra flexibility built into the statute from the special session. So we now have 18 months that we could look at to like raise and lower this. And so I think that, like thinking through this is, I know that normally when we when we raise the berm and then we lower it, we're like also then pushing and exporting, everything we collect, we're gonna have this huge flux to the north arm. And I don't know that this necessarily like captures all of that, during the course of that. But what if we thought that we were going to be in another drought year, what if we, impounded that, for like a full season, like an evaporative season, waited till November of 2027 to lower it, and then released it to the point where you could like equalize lake levels and then raise it again in February. You got a dynamic where you're like trying to maximize, imports and exports in the most beneficial ways, but also maximizing benefits of like, things like microbial exposure, dust hotspots, all the things that we're like trying to manage for. I know that's probably way too far out to look at the crystal ball that you have access to, but I think it's just things that we should be thinking about is like, what do we do in the spring of next year as well?
Exactly, right. And like if you raise the berm, the way I'm thinking about it is you kind of set yourself up, well, I guess not necessarily, but you kind of potentially set yourself up for an export situation. So even if you like hug these higher salinities, like we know we can export salt and other things really effectively. It's, so from what I have observed, we've all observed, we can create a valve in which we can lower salinity. And so you're right, it's thinking about all these different lags and levers, but it's pretty complicated. And then it's like, what should nitrogen be? What should X, Y, Z, A, B, C be?
How labile are the species that are biologically available, in salt water? Okay, how labile would nitrate or nitrate be?
Like my sense is that they're very labile and they're taking up because they're just very hard to measure. And many times it's below detection.
So what we're moving back in are microbes that can cycle, or what we're moving back in is nitrogen in what form? Is it ammonia that needs to be processed? Is it Like what exactly is the source of nitrogen?
Do the top line.
If we're
What's the-
opening the breach, what we're predicting that nitrogen will come back in, just based on this nebulous nitrogen. But where's the nitrogen coming from, and in what species? I don't mean species of bacteria or microbe. I mean species of nitrogen compound.
We can look at that. In more
Yeah.
detail.
Yeah, I'm just curious.
And I think that like these questions, I think this is where, if we did this for 5 months, we would
figured
learn a
out,
lot. And we would
Yeah.
also learn a lot about how much salt we can bring back and then
Mhm.
what the net flux would be when we lower the berm again. And it would kind of let us prove up on this idea that we can mess with the salt balance either direction. Because right now I'm always a little nervous that like if we start coming up fast, like, we don't have a great way to bring salt back. And so we need to get in the method of like keeping ourselves right in that good spot on the Iceman's curve, right?
Exactly. Does the state have the funding to do these extra experiments?
But we have some funding, and we can always ask the commissioner office to dig deeper into their pockets. I'm getting pretty good at that. So
Whoever that nebulous person is.
Is the state in favor of doing an experiment like this?
well, I think when you say the state, I can speak on behalf of Forestry Fire and State Lands. I think we really want to understand, how we can best manage this berm. I mean, we're tasked with several different public interests, such as the brine shrimp, flies, recreation, all these other things. So we're constantly, trying to be testing what we can do in this realm, because we can't really. Our division is going to decide what kind of inflows we get to create solid. So this is like one tool where we can kind of have some influence on what the different outcomes are. So I would say like our division is very interested, and we would push for like having information that allows us to determine like what is possible. But I think the state in general, I'm not speaking for anybody, but I think the state in general looks at this as being one of the most effective tools that we have in being able to manage different outcomes. So I think they'd be very interested in understanding what's possible, but also like with some safeguards.
Especially with it being low risk now and not being in a situation where you're really high pressure and a certain result.
Well, also we have a mandate at 4190 to raise the berm. So this year we're probably going to have to raise the berm in November anyway, based on what the statute says. So I think to prepare for the fact that we're going to be exporting salt come November, no matter what, we're not going to have the option to allow for any imports of nitrogen or salt. My inclination is like to prepare for that, and that maybe even maximize the benefits we get. For other purposes, maybe what we should be thinking about is let's import some stuff, because we know we can get rid of it if we err on the side of like too much. Like it's gonna be a really damn bad year for us not to be able to export what we need to. So that's my inclination, but there's a lot of smart people in service. That's why we have these conversations.
And this is not a driver, but I do want to highlight the fact there are hard seals that are of these permit where mineral return is not going to be allowed when it's limited to about 15%. If we're trying to solve for something else, I'd want to consider some flexibility on that, since this is kind of an artificial. We're creating this by management action. You're exposed to natural conditions.
Can you remind me again on the mineral return? Is that all based off of a point in time, or is it like a certain date that the salinity has to be at 15% or above, or like
We want to.
the time of discharge?
The way I read the rule is when it's above 15%, you turn them.
Okay, so
you turn that
you guys normally do your mineral return though in the spring, right?
We do it from November to April.
Okay.
It's based on a June 15, right? Salinity.
That's the lake elevation.
Yeah. Because in my mind, this is one of those things where like if that was not captured well in the rule, and we all discussed this when that rule was drafted. But if there was some need to modify the rule to reflect the fact that maybe that should be considered, based off of like spring salinities, if we're going to be doing these things, because like I think that's fair to consider that the management of the berm shouldn't really affect how you're going to do your discharge. And then honestly, if this goal of the state is to import salt, at some certain time, and then we're limiting your discharge of salt. It's a little counter to, so it sounds to me like maybe we need to think through. how
I mean,
to rule.
the rule is set up, based on information we had 2 years ago.
Yeah,
And we're in a completely different.
And I think we all
paradigm.
did our best to try and make something that worked for industry and then also that balance things for the lake, but I think that's why rules can be modified through administrative processes. Make that change if we need to.
Well, and the rule is just gonna thread through our updates permit, which is coming up for renewal. So, we can build in some flexibility for, purposeful management actions that,
Again, not trying to speak on behalf of another agency, but I would assume that water quality would be amenable to like looking at the rule if there's a real, issue with that. I mean, I know Candace is always looking for innovations, and so I would assume you guys could. Of course.
and those who attended the issues forum that I presented on the lake is below 4194. Like we're not operating the west ponds.
Right.
Just because we're kind of beating our heads against the wall. Evaporation exceeds pumping rate.
Right.
So we're less sensitive than we were like in 22 on north of our elevation, which is full promontory point, which has a very low intake. So lake elevation isn't a primary detector. I just wanted to raise that.
Well, just because I think we're probably 2 minutes away from being out of time here. What do you know, Jeff? When's our next meeting in June?
June 25th.
So we have a little bit of time. I'm just wondering if it makes sense, just because of the benefits that we're going to receive from opening the berm, if it makes sense to try to find a time that's sooner than that to be able to just do any of the last minute homework we want to do, and then try to make a decision sooner than that. I don't know that we even need to like fully convene in person. I wonder if this is something where we could just have a quick, meet. In person's always better in my opinion, but if we even needed to hop online for half an hour, run through some, any further analysis that we think is necessary, if there's any additional homework that needs to be done, and then try to get to brass tacks and get a recommendation. Or
I don't think we need another meeting. I think we could take a vote. And then if the vote is mixed, maybe we need another meeting. But I think the data that we have on hand is not going to change drastically in that time.
Bill, you had your hand up too?
Well, I'm a little confused because Christine's analysis, very nice analysis, Christine. It basically says, look, we're at the mercy of climate weather and we can tweak it, but I'm not even sure we can definitively measure the benefit between, the options. And so my take home is, look, we wait and see what happens because it's really all dependent on how the inflows evolve this year.
But we have a short window between June and November.
And I think another thing that Ben brought up is that changing the berm now allows us to understand how we can move salt. So when we look at your scenario results for next year, our salinity is okay. There's not much risk on the salinity standpoint. We may not be able to measure the nitrogen change, but we can measure the flux.
Yes, exactly. I was going to say that we will not be able to measure it in the south arm. We will be able to measure the changing flux at the new breach. We'll be able to measure those concentrations. You have the discharge. We can measure that.
Well, and just to go back, I think we know we're going to be raising the berm at 4190. It's a shall. We don't even have an option. We don't even have a meeting for that. We're just going to be raising the berm. So, do we want to prepare by bringing back, some nutrients and some salt? I think that's maybe just like in my mind, it just seems like there's not a whole lot of issues doing so.
I move that we take a vote.
It's just a cost benefit analysis. What's it cost to do that lowering of the berm in the meantime versus the benefit of doing that?
Yeah, it's probably free, to be honest. The railroad has been really cooperative, and I guess that would be part of the equation. And again, the Salinity Committee makes a recommendation. So if y'all recommend to our division of water quality that we should lower the berm and see if we can export that back, we'll go do our work and see if we can get the railroad in. And if it's cost prohibitive or if it's going to be too hard to be able to get a long boom out, we could come back and have that discussion. There may be some issues with it, to be honest. We haven't, like you said, we haven't lowered the berm yet. So
One elevation. What infraction are you thinking?
well, did you do your modeling based on 4187?
I assumed that the cross section is the same as it was pre-berm month.
was, oh, that was 4183, wasn't it?
4183, yeah.
So we raised it to 87 the first increment.
Yeah.
Raised it to 87, I believe.
Yeah,
Which
that's
just
correct.
cut a lot of the salinity. for the way it's
It
out.
did, yeah, it did all. Unless there was a wind event, yeah.
So that might, so there may be like, I mean, there may be some real issues trying to figure out how we get it down to 4183. That's gonna be hard for a piece of equipment to do that. So we'll have to see what the possibilities are.
I think, I mean, I guess I want to ask if someone wants to make a motion.
I did make a
for it.
motion.
Well, to, what are we gonna vote,
But like a.
to vote on? No, but I guess I'm bringing up your motion to
Okay.
vote and saying, okay, does somebody want to make a motion to vote upon?
Okay.
Because I think what
Right.
we're hearing is that we have an opportunity to run an experiment, where we would remove the berm, we would be able to test the bidirectional flow. What happens to the salt flux? What happens to the nitrogen flux during this 5-month period?
What was the berm elevation when we first opened up the breach?
83.
And that's what her model was based off of. So we'd be coming down quite a bit.
So Christine, these scenarios you basically lowering the berm 4100. That,
No, the flux estimate of pre-burn, like when I think about, okay, when I estimate these numbers and what we get back, it's really using data that were collected from 2018 to 2022, which is kind of a pre-burn modification cross section. And so, yes, in a sense, yes, I'm assuming that we get back to that in reality, which, I mean, there's the berm out, like the bottom elevation, and also the sides. I mean, but I guess that's less of a,
just think of it. That to make it worse. If we don't lower it enough.
I mean, right now, I think we're already seeing some north to south flow based on just the phenom. So anything we lowered, I think would have the
Greater
same
flow.
benefit. It just wouldn't be as much of a.
greater flux from the north, exactly. I think
A lesser flux of nitrogen and salt back into the south arm, but it would still be more than what it is today.
Based on the fact that we are seeing some return flow.
This is-
Where it is, okay.
For the record, this
Got
is the precise reason that we wanted to have something besides just a rock structure, because the challenge of lowering the berm or getting out and doing these modifications both ways, like it's easy to pile rocks, but it's not so easy to move these rocks or figure this out. This is going to be like maybe not free because I don't think people have the right equipment to do something like this.
Mhm.
So this is where having like a little bit more of an intelligent structure, come into play. Just for the record too, we are still looking at different options. Like we want to do some geotech to better refine, whether what's possible and whatnot. Just because we think it's important to be able to manage both directions.
Would the motion include a consideration for for what Joe brought up as the issue with discharge from mineral companies?
Well, I think, so you're saying like, we would need to do some analysis about where we think the salinity would end up to see if it's going to affect.
No, what I'm saying is that if we make a motion to lower the berm, but include in that motion that forestry, fire and state lands would consider the issues related to discharge.
Well, I don't think we can do that in a motion from the salinity committee because that's in the rule. So we would have to go back and work with water quality to modify their upkeep permit or their rule to do that. So I think that this decision has to be based on what we think we need to do today. And then if we need to look at rule changes, that would be something Jim would have to take back to his commission. Figure out what to do. But I would also say that I would think that if we were to get up to the 15%, and is it percent? Or
No,
is
it's
it
150.
150 grams per liter? Because I mean, we're just like, I guess worst case, we're like we're maybe getting into that scenario, or I guess,
I think it was
So
one.
I
this
guess-
is, I
actually
for
in
you.
most cases then. But we're gonna be barely edging on that, right? And come November, once the berm is raised, we're gonna start to see that salinity drop as we get fresh water in from the runoff at that point. So it'll be pretty temporary.
It'll be ephemeral,
Yeah.
but I've found comfort, with the salinity paradigm that we're in, that, we do continue to operate and then we're, taking a fraction of
Well,
what we normally.
So this is why industry's on the committee is. So you get to say how you think this will affect you. And if there's an operational change you can make where you can say, yeah, we can hold off for 2 months and not do our, flushing for those 2 months, maybe that's okay. I don't know how that affects you all, but this is where you guys get to decide how you want to represent yourself. So I'd just say, like, I could see why you would take that position, because that does make a difference. It's an operational change. And I also think that it would be worth exploring potential rule changes or whatever other things we can do as a state to make sure we're like really thinking this through.
I mean, our application's under review right now. Yeah, end of October. So I think we can, I plan to be with Lonnie and the team with water quality.
So I would just say, like, that's, if you, I would totally understand if you were not, supportive of this, or if we needed other, more evaluation, but.
I think your concern is definitely noted, and I think it's something that that the committee, would consider. We're making an artificial change to the berm, and there's gonna, we're gonna see what happens to we're experimenting to see how the salinity is affected.
Can I make a suggestion? I don't vote on this committee. I just try to give my thoughts, and they're usually not very well founded. But can we, because there's these different issues, these different regulations have kind of sprouted up, and also just a whole lot of other complicating factors, can we have some time to maybe meet with water quality, talk about like what the horizon looks like for a potential rule change or maybe an exception, and then try to come back and spoke another time? Because also we're actually like out of time, and I feel like this deserves a little more conversation as well. But can we also maybe just consider doing that meeting halfway in between?
Sounds like it, but it's field season, so
Yeah.
it's hard to get people in for
Understand.
meetings. Yeah.
So we could try to alter the time, like maybe we could start earlier in the day so it doesn't like end up ruining the whole day. It's just like from 8 to 9, or maybe we do it virtually. I don't think there's any reason we can't do that, but I think just getting,
Or if we
Yeah.
could vote by email, maybe.
yeah,
Is that possible? Is that in our bylaws?
I don't know. I think we're just kind of talking about maybe doing something between now and June.
So the outstanding question is how does this affect the salinity rule that PWQ?
I
has
think that's
promulgated?
probably the big thing, whether or not there's any exceptions to be made, because if our goal is to import salt, it seems pretty counterproductive to prevent Compass from doing their flushing.
Mhm.
So maybe revisiting that, and I know that was a huge lift with that rule, and we all tried to like capture that. So maybe just talking through what that might look like. And it sounds to me like a couple of weeks, especially when there's a different stage, it's not the most crucial time. It's slower. And we could also, and during that time period as well, we could also try to get a hold of UP and figure out like what they think is possible, whether we'd have to put this out for procurement. I think there's some like challenges about lowering it that much that I would like to investigate. You know what's possible, so we could do a little more legwork between now and then.
So we'll get a doodle poll out here today, tomorrow, and try to look for something next week and the following week.
Yeah, can you look at bylaws and see if email vote would be possible as well? Maybe this is as simple as just,
Right.
We send some email out and say, here's what we found, here are the 3 options. What's your thing? But we'll try to think it so it's, at this time.
Yep.
Is that okay with everyone?
Do you want more things to look at, or just do you want what we have?
I don't know. I think that most of what we need to look at has been pretty well represented. I think it's now just kind of like some logistics and maybe talking with water quality on rules, unless anybody else has anything that needs to be further analyzed.
I mean, not to make this decision, but to look at the long-term issues, I think the nitrogen, the comments that I know suggest.
So I think those action items were to look at the overall nutrient balance, look at total nitrogen, consider sampling intensity to capture the balance, and then look at the form of nitrogen in the north to south well. So those are ongoing things we can be working on. I think the key thing here is just to think about potential concerns about, and I think the way this is framed is as an experiment for a number of months before November 1st. I think assuming that we have to raise the berm to 4190 in November, can we lower the berm down to 4183 to look at how the flux changes? And And I guess we'll have, I think, looking at the monitoring intensity to understand the flux changes.
That's actually a good point too, Jeff. Maybe one thing I would ask that if there's a way to look at this, Christine, and I know this is like pretty hypothetical, but at what point, you know, knowing that we would go down to like 41, what was it, 90? What was the elevation we would hit at the bottom? That was it 4189.3.
Yes.
Okay,
this
so-
fall.
So maybe like at what date, if it's possible, you would anticipate that we've hit 4190, because it may be that we have to raise the burn in like September, and maybe this is a little too much just to consider 2 months worth of import. Because we shall raise it to 4190 or at 4190. So I don't think we get a whole lot of discretion there. So
Yeah.
so maybe just understanding that as well.
Honestly, I mean, I don't know how, I could look at previous rates of decline, but I mean, this year I'm thinking about evaporation and also just like the abysmal runoff.
Yeah.
And so it's like, what are inflows going to do? Are they going to be impounded upstream? There's like a lot of things I can't really predict. It would affect the slope of decline.
Well, and no, you don't need to like put out a number, just put out a number. I think maybe that's just something else for the group to consider, is that we may need to think about the fact that we may not be able to wait till November to actually raise it. It may have to happen like, you know, August, September, like who knows what will happen. So
I
just another
can
factor.
put together something based on previous rates of decline and give you some idea, but
if you think
just so you know, I
there's-
have no
yeah, if you think it makes sense, then that'd be awesome. But if it doesn't seem like it's by a ton of value, it's not very worthwhile. That's fine too.
So then, and then I think the last action item is just logistics on moving rock.
Yeah.
Um,
We'll do that on our end. We'll work with the UP and others to see what potential there is.
Christine, could you put your Venmo up there so we can all tip you?
Thanks, Patty. Appreciate that. I'll bring it to Jen.
Hey, I asked David to give Christine a raise during the issues for, so hopefully that's on that check.
I'll
Yeah.
take time. I know. I'm gonna start like looking at different places. Thanks, Christine, for all your basic work. You're welcome.
Thank you.
And USGS, and the state for funding, yeah, great.
All right, well, thank you, everybody.
He does have Robert.
We did. But,
I know. Behind them. That was.
Okay.